When theta is small, show that the equation 1 plus sine theta plus tan 2 theta can be all over 2 cos 3 theta minus 1 can be written as 1 over 1 minus 3 theta. Right. First things to note is when theta is small, this is specifically for when theta is small, sine, well, let's not put theta, let's put a different letter. Sine x is approximately x. When theta is small, cos of x is approximately 1 minus a half x squared. When theta is small, tan of x is approximately x. So we're using these facts and we're going to substitute into our expression. So we have 1 plus sine theta plus tan of 2 theta, all divided by 2 cos of 3 theta minus 1. And that's approximately equal to 1 plus. So sine of x approximately becomes x when the angle is really small. So therefore, theta is approximately going to be theta. Tan of x is approximately x when x is small. So therefore, tan of 2 theta is going to be approximately 2 theta. At the bottom, we have 2 cos of x is approximately 1 minus a half x squared. So cos of 3 theta is going to be 1 minus a half of 3 theta squared. And then we put the minus 1. So all I've done is I've replaced sine theta with theta, because that's approximately what it equals. Tan of 2 theta with 2 theta, because that's approximately what it equals. And I've replaced cos of 3 theta with 1 minus a half of 3 theta squared, because that's approximately what it's equal to. All good so far?
Yeah.
Yeah.
Okay, so now I'm going to simplify this. So this becomes 1 plus 3 theta at the top. At the bottom, I have 2 open bracket 1 minus 3 theta squared is 9 theta squared, and times that by half, it's 9 theta squared over 2. And then subtract 1. That's equal to 1 plus 3 theta, all divided by 2. So if I times the bracket out, I get 2 times 1, which is 2, minus 9 times 9 over 2, which is 9. And then I have the theta squared, then minus 1. Then that becomes 1 plus 3 theta, all divided by 1 minus 9 theta squared. Now, conveniently, the bottom, we have to get good at spotting these, factorizes via the difference of 2 squares. So we have 1 minus 3 theta multiplied by 1 plus 3 theta. And now we have the 1 plus 3 thetas that cancel at the top and bottom. So divide the top by 1 plus 3 theta, you get 1. And divide the bottom by 1 plus 3 theta, you also, that portion or that part also simplifies to 1. So you're just left with 1 over 1 minus 3 theta as required. Any questions?
No. Oh, that makes sense.
Cool. And then with part B, it says write down the value of 1 plus sine theta plus tan 2 theta over 2 cos 3 theta minus 1 when theta is small. Well, if our expression is 1 over 1 minus 3 theta, if it's saying when theta is small, that means that theta is tending to 0. It's really, really tiny. So imagine actually substituting in theta for 0, you'd get 1 over 1 minus 3 lots of 0, which equals 1 over 1 minus 0, which equals 1 over 1, which is just 1.
Wait, so for the second one, when it says to put theta when it's small, you just put 0?
Yeah, because what small means is extremely tiny when it's close to 0. So this has to do with limits.
All right. Okay.
Okay, so then with that in mind, let's go on to slide number 8. So it's the one that Kieran's already on. So using those results, can we try this question then? So I'm going to give you some time to try. And again, it's using the fact that when x is small, when the angle's small, sine x is approximately equal to x, cos x is approximately equal to 1 minus a half x squared, tan x is approximately equal to x. So I'd say maybe collaborate between the two of you before I intervene.
Okay. So
You can write your ideas on the Jamboard. Try to, but if you can't, then
so I substituted in the small angle approximations first, and then I expanded it, and I think that's where I went wrong, because I got 2 take away a half theta squared, take away 3 plus 3/4 theta to the power of 4.
I'm still a bit stuck as well. I'm still trying to figure it out. Yeah, I'm pretty stuck.
Kieran, what have you done so far?
I'm not really sure where to go from like the first bit. I'm still trying to figure out where to go first.
So, what did you do to begin with?
I substituted in the small angle approximations, and I got 1 plus brackets 1 take away a half theta squared, and then close brackets minus 3 open brackets 1 take away a half theta squared, and then I squared that. And then I expanded it, and I got 2 take away a half theta squared, take away 3 plus 3/4 theta to the power of 4.
Okay. And then if you simplify that?
But then if I simplify it, I get -1 plus 1/4.
Wait, just -1 plus 1/4, that's it?
And no, -1 plus... Oh, I forgot there was a 4 on the theta.
Okay.
I know I'm still stuck.
Okay, let's do this in one way. Right. So we substitute. So cos theta becomes 1 minus a half theta squared minus 3 lots of, and then cos squared theta is 1 minus a half theta squared. Then that becomes 1 plus 1 plus 1 is 2. So we have 2 minus a half theta squared minus 3 times, and then expand this bracket, we get 1 minus theta squared plus 1/4 theta to the power of 4. If you put the two things side by each other and expand, you'd get that. Then we'd have 2 minus a half theta squared minus 3. Now expanding this bracket with the minus 3. So minus theta times 1 is minus 3 plus 3 theta squared minus 3/4 theta to the power of 4. Then 2 minus 3 is minus 1. Minus a half theta squared plus 3 theta squared is 2.5 theta squared, which is the same thing as 5/2 theta squared. And you've got this extra minus 3/4 theta to the 4. Now, this is where the other bit is important to know, because we've got this extra minus 3/4 of theta to the power of 4. Because we have small angles, if you imagine a really small number, like 0.000000001, kind of small, if you were to square that number, would the answer get bigger or smaller?
Sorry, which number?
A number like this.
Oh, it would get smaller.
Okay. And then if you raise that number to the power of 4 now, so if you imagine 0.00001 raised to the power of 4, that's going to be smaller, like even smaller than that. So since theta is small, we can neglect minus 3/4 of theta to the power of 4, because it's going to be really small as well. And typically in the A-level course, we are allowed to neglect terms that are in the cubes or more for this kind of thing. So this now becomes minus 1 plus 5/2 theta squared. Oops. Okay. Let's try this another way. The same question on the next slide. But instead, let's use the fact that cos squared of theta is identical to 1 minus sine squared of theta. So try the same question again, but use the fact that cos squared of theta is 1 minus sine squared of theta. So slide 9, now you can discuss, because you've got the ideas from the previous one. Have a go.
Sorry, I don't understand what you mean by like wait, can you repeat what you want us to do?
So on slide 9, we're doing the same question again, but rather than using cos squared theta, replace cos squared theta with 1 minus sine squared theta.
Oh, okay.
Okay, so have we made progress?
Yeah, I've done it.
Cool. Kieran?
Almost got it.
Cool. Kieran, how have you started? What did you do?
So I substituted them in, and I got 1 plus 1 minus a half theta squared minus 3, and then in brackets 1 minus the theta squared.
Mm-hmm.
And then I expanded the brackets and got minus 3 plus 3 theta squared.
Mm-hmm.
And then I did expanded. I figured out what was outside the bracket,
Mm-hmm.
which is 2 minus a half theta squared. And then I just needed to work out from there. So
Okay, sounds good. So yeah, we've replaced first of all cos squared with 1 minus sine squared. 1 plus cos theta is the same thing as 1 minus a half theta squared, or roughly anyway. And minus 3 open bracket 1 minus, well, sine theta is approximately theta, therefore sine squared theta is approximately theta squared. So then we get 1 plus, well, 1 plus 1 is 2. So we have 2 minus a half theta squared minus 3 plus 3 theta squared. 2 minus 3 is minus 1. And then minus a half theta squared plus 3 theta squared is going to be plus 5 over 2 theta squared. And there we go. So yeah, we got it. And then this last question will be good to try at some stage as well.